Hi everyone, my name is Casey. Today I'll be going over labs 9 to 12 and then towards the end talk about the bioculture that we chose or that I chose. Um, let's get started. Just a brief introduction before we get started. My name is Casey Mendez. I'm 23 years old, and this is kind of like an example of what speaks highly of me, animals. I love animals. As you can see, it's kind of different animals. Um, on the left hand side, the black and white doggy, that's my Pomeranian. He's 9 years old. He's a I do what I do. In the middle, I have my other doggy. Her name is Lily. She is a she's a German Shepherd. She's in her seventh years right now. Um, and then on the right hand side, we have our chickens. So my parents decided to move to Alpine recently, and as you know, Alpine is the countryside of San Diego. There's a lot of land there, and I think they just got tired of the city, so they wanted something more rural. They didn't even take me into consideration because I'm a city girl. I like the city. Um, so it's been tough living up there, but we have 60 chickens, we have 2 turkeys, 2 peacocks, 2 ducks, and a tortoise. So it's definitely crazy up there, but they love it. They're thriving. Me, not so much. Um, but yeah, so as you saw, animals are a pretty big part of my life. Um, so kind of shifting into it, my career, what I do. I just recently graduated from the master's program at Mesa, May 2024. Super excited. Oh, what the heck? Super excited about that. I love that field so much. I just love taking care of animals. However, if you are doing it just for the love of animals, you're not going to succeed in this field. It is quite literally the most expensive field ever. You see the most horrific things in, especially when like it's abuse towards animals. Like it's just so heartbreaking. But I do it because I have such passion for helping animals. But yeah, I love anesthesia monitoring. It's a bit of a component of it. Um, and then if you still look at the next slide, this is a doggy that came in. His foot got stuck on a fence. We scooped it up and then he was right back out and he was super happy. But just a brief little thing of like what speaks highly of what I am all about animals. um, yeah, so now into what it is, what we came for the lab. So we're gonna talk about lab 9, lab 10, lab 11. Lab 9 has 2 parts. So starting off with the first part, plasmids. Um, for this part, the goal of this lab was to prepare plasmids and use the preparation techniques. So the first part is basically just the isolation and purification of the plasmid PARA from the E. coli cells that we're using. So, sorry, quick overview of plasmids. They are small circular double-stranded DNA molecules. They're found primarily in bacteria. They range from size from 1,000 to 2,000 base pairs. They often carry non-essential genes that provide advantages. So for this one, it's antibiotic resistance, and then the E. coli cells that are looking at contain plasmid PARA that carry the gene for ampicillin resistance, fluorescence gene, and the ARA gene, which is the slave resistance. So yeah, so there's the materials on the left hand side, and then for part one, the procedures was the first part we did carbon bacteria cells. So we transformed 1.5 milliliters of E. coli culture um, that contained the plasmid RPARA into the microcentrifuge. And then we centrifuged that for 2 minutes and let the cells pellet all the way to the bottom. After that, we centrifuged it. Um, sorry, after we centrifuged it, we sometimes it's for it. Or we actually didn't dump it out. We micropipetted it out. We have to be very careful because micropipettes can be like I can suck out the plasmid and we honestly that. But yeah, we repeated that step until we did a total of 3 milliliters of the cell. Um, After that, we suspended the cells. So we centrifuged it again to bring back everything down. And then we added 110 microliters of ice cold to the suspension buffer. And then we vortexed it to the suspended pellets around the first. And then some cell lysis. So we added 50 microliters of FCS and 50 microliters of NaOH to lyse the cells. And then that was given a good mix, and then bring it to the pump, and then we incubated for 60. And then comes after that comes in nat neutralization of precipitation. So we added 120 microliters of isocold potassium acetate to neutralize the negative charge. Um, and then this kind of helps with the plastic for the following after the neutralization is interpretation of the single-stranded cellular DNA and the SPS. So we bring back down all the material that was up there. Going into the future. Yeah, and then the plasmid DNA specification, that was everything that's up there. So then we transferred 300 microliters of the supernatant, which contains the plasmid DNA and to a new tube. And then we added 200 microliters of isopropyl onto that. And then we mixed and incubated for a minute until the temperature within minutes, something that the DNA pellet. Um, and then we washed it, and then we just, again we put a micropipette of the supernatant, and then we washed the pellet by adding 500 microliters of 70% ethanol. And then we substitute it again, and then because of the ethanol, we made a 20-minute cancel out evaporation because it has a higher it can evaporate quickly with alcohol or ethanol. And then we store the pellet in the freezer and come back to after practice. And I know some people love diagrams. I, for one, love diagrams. They just kind of give you the everything and kind of helps you look at it better. But yeah, so again, we take the colonies, we centrifuge clear, we integrated, extrusion, we descended, and again, an important part is life cells, and then neutralizing it, and then stuff. Um, so isolate. So yeah, and then we purify it with that. And then lab 9 was part 2. So this is the research enzyme. So we use two very important research enzymes. We use BAMH1 and T3. And then these research enzymes digested the plasma DNA and created specific fragments. These specific fragments are done in a palindromic sequence, meaning it's read the same forward as it is backwards. So for example, 2002 or 11. And again, what they do importantly is cut the DNA. And then we will be using the RFP protein. Or we use those and then in the RFP protein. But yeah, and then the lab assisted enzyme part 2. Again, this is following with the procedures. We from the part 1 we used there, we brought it back, and then we worked in pairs to set up the tubes again. So student pair 1, which is Helena, and then student pair 2, which is Nick and Ryan. They did tubes 3, 4, and 6. Um, yeah, I just kind of put like a diagram of what we needed to put into those tubes. After we added the enzymes, we tapped abundance first again, and then we put them into a 37 degrees Celsius bath and acidic containers. Um, and then lab 10 is the DNA gel electrophoresis. So for this one, we use agarose gel electrophoresis to separate DNA and RNA, or to separate the DNA. And then we view them under the UV light, and we stain it with gel green to see and compare with the DNA ladder to see how much it migrated. And again, I put another picture just to help people visualize. But we load the protein sample, apply the current, so obviously negative charge, negative positive, depends on where they go, and then we analyze it. Okay, so for DNA gel electrophoresis, these are the materials that we use, and then for the procedures, we prepared the agarose gel. It was quite a bit of preparation for it. So there's a calculation that you have to do for that. But we weighed 0.2 grams of agarose and then added it to the 125 milliliter flask. And then with that flask, we added 20 milliliters of sodium boric acid sulfur. And then we put the mixture in the microwave for 50 seconds. If the agarose completely dissolved, then we added 10 microliters of the pill being dyed to the melted agarose. Let it cool out for 5 minutes, and then after that, once it's cooled, we poured it into a 9-well chrome plastic tray. Then after that, we let it solidify at room temperature for like 10 minutes. Once it's hardened, we remove it from the and then we place it into the gel tank, and we add 125 milliliters of sulfur to cover the gel. And then we prepare the DNA sample by adding 3 microliters of the loading buffer mixture into each of the 20 microliter digestion samples. And then we flash spin and then centrifuge bring up down. And then these are the procedures continued again. So now we're loading the gels today. There's 7 different lanes. 1 and 7 were actually we didn't even use. It was kind of uh like controls. We didn't actually put anything in there. We used 2, 3, 4, 5, 6. So Helena did 2, or yeah, Helena did 2, I did 3, we coded 4, I did 5, and I think that's 46. But we ran the gel once it was filled, we put it under the UV hood. We let it run for 30 minutes, and then after that, we're able to take a picture with it on the phone. Actually see it in the TV. So yeah, we completed the migration of the DNA, compared it to the DNA ladder to the chemical side of it. And then this is kind of like this is the one that you use. I think once we the lane forward, you kind of see it right here. It didn't really migrate. I don't know what happened there. I think, yeah, I don't know what happened there. But we compared it to this DNA ladder here, to see what size it is. Yeah. And in lab 11, the bacterial transformation component. So essentially, we're just adding a foreign DNA into the bacteria, uh, and then we're just introducing them to each other, and then seeing in um, their behavior basically, and then obviously transforming their food and the kind of formulated. I just like my coffee. Um, yeah, and then the plasmid contain the RSP, which is a red fluorescent. So if you successfully did it, then you'll see those little red bacteria. But yeah, and so this is the procedure for it. We labeled 2 microcentric tubes, one as positive and one as negative, and then we all had our own tube as well. So we had 250 microliters of actual transformation solution, and then we let it kind of chill there for a bit. And then I'm gonna just kind of show like this one because it has all of it together. But for plate one, it had the LB, only the LB, and the LB, which is Luria Britannia, that one has, it's like really culture rich, so it's expected for a lot of bacteria growth. And then plate two, it's just LB, ampicillin, which ampicillin is an antibiotic, and the E. coli without the plasmid. So we don't expect growth of that one. For plate three, we have LB, ampicillin, and E. coli with the plasmid. So we expect a little bit of growth of that. And then plate four, that's what we're expecting with the red little uh, fluorescent dots because that one has the arabinose. But yeah, so we let them incubate for like 10 minutes. And then these kind of the results. But this is the results of the overview. In this plate, obviously plate one, you can see all the growth. It's absolutely big count. And then two, again, we expect nothing, we see nothing. Plate three, we kind of see over here all the little, I think we only see like 5. I didn't expect that much. And then plate four, the rest of the diet, so one here, and then here. You can see on the graph. But yeah, so to finish it off, talk about my biotech career. So I chose the animal technician because that's kind of exactly what I'm doing now, or the career I'm in. So of course I would take this, but the job duties obviously is just for animal tech to keep record of any tasks associated with any animal. They help the veterinarians, researchers, scientists, anybody working in the research field. They perform tasks such as drawing blood, creating sites, creating figures, all of which I'm familiar with because I've already done. So that's why obviously I chose it. We have to be able to lift up, a good amount of pounds because it's pretty heavy. But yeah, we just have to talk to the supervisors, be able to interact with them, be able to make ac- accurate observations, in order to keep data current because we all, if you're working in the research, if you're working with dogs or animals that are under. But yeah, so an overview of it, we again just help around with the veterinarian. Um, and then again, the reason I chose it is I have a passion for wanting to take care of animals, and on top of that, I feel like humans also need as much as animals need that help. Humans need to, and animals help us. Again, I don't think we would be alive if it wasn't for animals. To be honest, they do the drop work of it all. But yeah, this is pretty much it. This is the self I chose. That tech oncology. Oncology, you know, is cancer. Working with cancer. So you see, I did do. I was one of my vet professors was she worked in oncology, so she talked to me a lot about it. But it is kind of depends. you see, anime this chapter. Um, but again, I am in it for the passion, not for the love of it, because I would probably maybe be sad if I just did it for the love. Um, but yeah, so this is the one I chose. And thank you for listening. Can you do it? Please.